Hello, my name is Jianming. I'm a technical support engineer in Diana. Today I'm going to introduce the tutorial called Staggered Structure Heatflow Analysis of Early Age Concrete. So first I will introduce you the geometry of this model. So the bottom is the soil layer, and on the top of the soil layer first we cast the base concrete on top of the soil layer, and then we cast the separation wall on top of the base concrete. So after the geometry is set up, we move on to the material setting. So we will assign, in this case, the linear elastic material properties for both concrete and soil. And then we will set up the boundary conditions for structural analysis and also for transient heat flow analysis. For example, the convection between the concrete and the air, and also the initial temperature as well as the fixed temperature on the boundary of the soil. And then we will set up an analysis for this simulation. There are three types of analysis that are used in this model. The first type is phase analysis. In the first phase, we will simulate the casting of the base wall on top of the soil layer. And in the second phase, we will simulate the concrete wall building on top of the base. Both phases consist of 36 days, and the first 7 days of both phases are simulated assuming that the concrete is contained by the frame. And after day 7, the frame is removed, and then we will simulate the convection between the concrete and the surrounding air. And after transient heat flow analysis is defined, we will move on to the structural nonlinear analysis. Then in the end, we will show you the result. For the concrete, we will show you the temperature development of the heat of hydration from the concrete, and we will also show you the stress development inside the concrete as well as the crack index, a valuable parameters that is used to identify where the crack will potentially develop. Before we move to the demo, I would like to inform you that it is very important to choose a correct mesh order for staggered structural heat flow analysis. The reason is listed in this slide. So if you have a linear heat flow elements, then the temperature will be linear in the element as well as the calculated temperature field. And then this calculated temperature field will automatically generate a load for the structural analysis. And this automatically generated load is linear in strain, quadratic in displacement. So if you use a linear structural element which is constant in strain and linear in U, there would be a discrepancy between the generated load and structural element. So you need to use a quadratic structural element which is linear in strain and quadratic in displacement, so that the automatic load generation can be used to assign the load on this structural element. Without further ado, let's start the demo. So first thing to do is to start a project. In this case, we will name this project separation wall, and for analysis we will need to select structure and heat flow analysis. And the dimensions, we need to select plane strain as we mentioned before, and size will be 100 meter. And as mentioned before, we will need to choose a quadratic mesh order. And in this case, we will use linear interpolation because the structures are flat and straight. So we'll click OK. And after a few seconds, the project will be generated. And first thing to do is to check the unit of the setting. So by default, we want to change the second to day and the temperature Kelvin to Celsius degree, and we want to keep the force as Newton. And now the unit is ready, we start to create the geometry for the model. The first thing to create is soil layer. So we use a coordinate input for this the geometry. We will input the coordinate based on the tutorial. Now the soil layer is created. We will create base concrete, and we will input the coordinate again from the tutorial demonstration. And then for the wall, we do the same. Please note that here we use a phi coordinate to generate the soil, and the base concrete is because we would like to assign a temperature on the edge. You can also skip this by assigning only 4 points, and you use imprint after the geometry is set. So now that we have the geometry ready, next thing we do is to assign the material properties. So we start with the soil layer. We select the element class plain string, and we add a new material called soil. The class you will choose soil and rock, and we use linear elastic isotropic material in this case for simplicity. And we also need to activate the thermal effect and the heat flow in order to take into the account of thermal expansion of the material as well as the heat flow coefficient. So we also fill in here the parameters based on the tutorial. Young's modulus, Poisson ratio, saturated density, and the expansion coefficient. And we also need to fill in the heat flow conductivity as well as the capacity. And then we click apply. And next we assign the material properties for the concrete. So here we select the element class plain string again. We add the new material called concrete. And the class will be in this case we will choose the concrete design code, which is already developed in the Diana. So you can choose plenty of different concrete design codes. It's already available here. In this case, we will choose the Japan Society of Civil Engineer Material Concrete, and we will choose early age analysis as well as the heat flow parameters. As you can see that all the parameters is already pre-filled, and for example you can also click here to see the Young's modulus developed based on the maturity, compressive strength and tensile strength, and adiabatic heat development based on the age, as well as the other parameters is also predefined as well. And we click close, and we apply. And now we have the material model ready. Next thing we want to do is to apply the boundary condition on this model. We first start with setting up the heat flow boundary condition for the base concrete. So first we create the connection for the base wall, and we call it sub boundary, slab boundary, which is located on top of the soil layer. And connection type, we need to choose boundary interface, and for edges we need to select all the edges belongs to this base concrete that is exposed to the air, and select flow boundary, and add a new material called interface base, and the class we will need to choose heat flow, and then click OK, and we need to fill in the heat transfer coefficient. Because we are simulating the effect of removal of the frame, of a concrete frame, we will need to define a time-dependent heat transfer coefficient. We can do this by click this button, and we can fill in the data point here based on the time and the heat transfer coefficient. And we start with the original number and all the way till the 7th date, which is the removal of the frame from the first the base concrete, and all the way to the end we set it to the same number, and we create. And now you can see that the green symbols, which is the boundary elements, is setting up on the base wall. The next thing is to create the boundary condition for the wall. Here we name it wall boundary, and we will need to select all the edges that is exposed to the air, these two. And element we choose the same, but the material we need to make a new one, because the time factor for the heat transfer coefficient is different for the wall, because the different casting time and also the removal time for the frame. And we fill in the same number again and same time dependent, and we start with 0 day with the original number and all the way to 43 days, which is the 7 days after the casting of the base wall. And then right after the 43 day we will increase number to simulate the convection from the air. and all the way to the end we fill in the same number again, and click close again, and we click create. Now that all the heat flow boundary conditions are setting already, and next thing we want to assign the fixed temperature for the boundary of the soil, and here we call it fixed temperature soil, and we add the boundary condition set as fixed temperature soil. We use the same name, and we select this edge that is outer soil, and we fill in the temperature of 15 Celsius degree. In Diana, in order to prescribe temperature, you will need to fix the temperature first. So in this case, we can click this button, and you can see that all the three edges are already selected, and we just need to add the new fixed temperature set here, and we click create, and then you can see in this box it will be filled in already, and we click create, and now you can see the symbol represent that the temperature is fixed at the edge of the soil with a 15 degrees Celsius. And next thing, we will also need to do the same with the external boundary for the convection, because we already assigned the connection, and we also need to assign the external temperature so that we can calculate the convection from the air. Basically, we are assigning the temperature from the air. So here we call it external temperature, and the target type will be edge, and the external temperature, and the external temperature with 20. And because you see that we assigned the connection already, it's already here, and then we need to click create, and then the external temperature is assigned for these two boundary elements. Next thing is to assign the structural boundary condition, and we will also need to assign a time factor for this, because we are doing a time transient heat flow analysis, and we will click this button to edit the time dependency factor, and we start with the day, start from 0 day, the first beginning is 1, and then 72 day as 1, so that it is activated in this case, because we already previewed the number. And we do the same with the external temperature as well. And then we will have all the thermal boundary condition ready. And the next thing is to assign a initial fill, because if we don't assign initial temperature for this model, then we will assume the temperature begins with 0 degree. And here we call it the initial temperature soil, because they are different with the concrete. And we add only one set. We call it initial temperature for both soil and concrete, the same set. And we will select a shape and temperature, and we click the soil, and it will be a 15 degree initial temperature for the soil. Click create, and you also do the same with the concrete, and we will call it initial temperature concrete, and the initial temperature will be 20 Celsius degree. Okay, great. And then we have the initial fill ready, but before that we also need to do another one, is that we assign the edge of the concrete, because these two, they are shared by the soil and the concrete. And we choose the base, and the initial temperature will be 20 Celsius degree, so that we can make sure this edge is 20 degree. So yeah, and then we will have the initial temperature ready. And next thing to do is to assign the structural boundary condition. Here, because we are assuming the symmetric characteristic of this model, we will use a horizontal support to represent it. And we create a new set called support, and we select the symmetric axis, and we fix the x direction as well as the other sides, because we assume a lateral extended soil. And then we will also need to support vertically the bottom of the soil. And then we have the boundary condition ready. And then we will need to assign the gravity. Here we make a new set, and that way click create. And we have the load ready as well. And now we have the whole setting ready. We will need to assign the mesh property of the model. In this case, we will, because we are more interested in the concrete, and we will decrease the soil mesh size a little bit. We use a relatively large number compared with the concrete, and we will choose hex and quad for the soil. And for the base, we will make it a little bit finer, 0.16, and then we choose the wall because it's small. Then we also want to make it small as well, 0.06, and we click apply, and we click generate mesh, and we have the mesh ready. And next thing to do is to set up the analysis. First, we will need to set up a analysis, the phase analysis. So right click, we rename this as phase analysis, and we will need to add the command phase. So in this phase, we will only activate the base and the soil, as we remove the wall and the convection boundary condition for the wall. And then next, we need to add the transient heat flow analysis. In this case, we will need to assign the initial temperature as we set up before, and start time will be 0, and we want to set a nonlinear analysis because we want to calculate the heat of hydration and also the equilibrium age to take into account the developing material properties. And then we will input the step size based on the tutorial. We'll just copy and paste here, and it will set up, and then we will need to select the output. In this case, we use default, and we will add the structural nonlinear analysis, which will make use of the temperature from the transient heat flow analysis. And in this case, we will remove the load step and then add the new start step, and we will need to add the additional load, that is gravity, and we can close, and we will need to add the time step. In this case, we will use the same time step as we previously defined in the heat flow analysis. And output, we are interested in displacement and also the total Coulthard strength, global strength, and also crack index. And the next thing you want is to check the material properties developed. And then we continue with the second phase. And we add the new phase. In this case, we will activate the wall and the wall boundary, and we duplicate the previous transient heat flow analysis and also the structural nonlinear analysis. And in this case, we will need to change the initial condition, the start time, from 0 to 36 day, which is the beginning casting of the wall, and we close. And for the structural nonlinear, we will also need to adjust the start time to 36 day, and we deactivate the additional load and use the previous load, and close. And for time step, we will keep it the same as well. It is already assigned in previous analysis. And then we have the analysis setting already ready, and we can just click start analysis. Now that the simulation is finished, we want to check the result. So here we would like to hide the soil result because we are only curious about the concrete. So first we want to see the degree of freedom. So here we would like to constrain the result to fix the contour proc limit so that we can see different values. So the specific value will be from 0 to 1. And as time goes by, you can see the degree of freedom is changing with the time. And if you go to the second analysis, then you can see this wall is also changing with time. You can also see the temperature development over the time here, but we need to change it back to 20, and this will be 50. And if we start from the beginning, you can see that the heat of hydration of the concrete, and then the heat is reduced, and then eventually the temperature reduced to the normal level. And then if you want to go to the casting of the wall, then you can see the temperature is also increasing as well, similar pattern. And then if you want to see what is the temperature development of the center, then you can use the one provided by the tutorial with a Python script. Select here and go here, then all these 5 nodes will be selected, And if you say show table, then you can see after the casting of the base concrete, the temperature is increased and then slowly drop, and the casting of the floor is also making the temperature increase and slowly drop to the surrounding temperature. And if you want to see what's the temperature developed on this location, you can use the function called probing curve. So in this case, the probing curve will be located in this direction. You just create a new curve and need to input the coordinate. In this case, will be 0, 3.4, and the next one, which is 126, 3.4. They will be like this. And you can also add point based on this function. Then you can click location as you want. Click OK. And then if you show the contour plot, then you can see the temperature changes. For example, if you want to go to the beginning of the 2 day at the day 2, then you can see this curve is changing with the time. You can also go to the 38 days, then you can see the temperature of this location is changed. Next thing we want to see is the crack index. So crack index is the ratio between the tensile strength and the maximum principal strength. The ratio, when the ratio is larger than 1.5, it is unlikely to form any crack. If the ratio is lower than 1.2, then it is very likely to form crack. So we adjust the limit from 0 to 1.5, and we also need to change the color limit so that it matches our visual intuition. And you can see that with time going, the concretes are more likely to form crack. If you go to different time, you can see this more obvious, as well as the wall as well. You can also hide the data outside of limits so that you can focus on the interest part. And you can see the crack are more likely to develop in the center of the concrete. You can also see the Young's modulus change with the maturity. We need to adjust the maximum value and also the minimum value for the Young's modulus, as well as the color to make it more intuitive. The minimum we will change it back to 1.5 E9 and the maximum is 3.3 E10. And you can also start from the one node phase, then you can see that the Young's modulus is increased with the time for the base wall as well as the cast wall as well. Same thing can be seen in the tensile strength. We need to adjust the minimum and the maximum value. Of course, you can choose to use the automatic value. And from the beginning, then you can see that the tensile strength is changing with time as well. The tensile strength is now increased with time, as well as the top wall. This will be the whole tutorial demo. If you are interested in reproducing this demo, you can go to the Diana website, Get Started Tutorial. This tutorial is under the category of structure. If you go down, you can find the tutorial of this one. In the same time, you can also find other tutorials that might be interested in for your project. And you can also make use of the manual of Diana, which you can find a lot of information here. Thank you so much.